Hey everybody, here's another example of using the law of sines and cosines to solve some application problems. So here I have a ship traveling 40 miles due east, then changes to a northward direction. When the ship has traveled 30 miles at this heading, it's 56 miles from the point of departure. Find the bearing from its point of departure and when it changes course. So this is a two-part problem. I'm going to need to find the bearing from its point of departure. And remember, bearing is always made with the north-south. So this is the angle that I'm looking for. And then also when it changed course. So I'm looking for this angle here, again made with the north and east. So two problems. Let's see. If I want to find this first angle here, if I know this angle x, I can just subtract it from 90, and we can see in our triangle that we're given a side, side, side case. Now that right there gives us a law of cosines to use. So I'm going to first use the alternate form of the law of cosines to find that angle. So the cosine of x is going to equal the two adjacent sides, so 56, so 56 squared plus 40 squared minus the opposite side squared, all divided by 2 times 56 times 40. And that's going to give me the cosine of x. This top will come out to be 3836. And 2 times 56 times 40 is 4480. And when I inverse cosine that, inverse of 3836 over 4480, I get approximately 31.1 degrees. So that is this angle right here. Alright, that would make my bearing then for theta, my bearing from my point of departure, 90 minus 31.1, which is 58.9 degrees. And so that is north 58.9 degrees east. There's my first bearing from my point of departure. My second bearing is a portion of this angle where I made my turn. Call that T. And you should notice that it's going to be 90 plus whatever this angle is. Well, if I find this whole angle, subtract the 90, and I'll get my answer. So again, law of cosines using the alternate form. This is going to be the cosine of t, which will be the two adjacent sides, 40 squared plus 30 squared minus the opposite side squared, divided by 2 times the two adjacent sides. That's going to be negative 636 over 2400. So when I inverse cosine that, angle T, negative 636 over 2400, I get 105.4. So 105.4 degrees for angle T. Now, my bearing angle, call that theta 2, is going to be the 105 minus 90. So that's going to give me 15.4 degrees for theta 2. So that bearing is a north 15.4 degrees east bearing when I turned. And there you go.